We're going to start off with a super fun topic involving a lot of statistics, so I apologize. All right, so I'm going to present today about A/B component testing in the land of the virtual DOM. My name is James Villarrubia. I'm currently the CTO of a company called Work. It is focused on delivering kind of corporate insights based on employee flexibility, kind of how you make flexibility work in the environment. I have a bit of a side hustle with my friend Bernie called Mount Cleverest. It's a free online textbook of AI. I've been VP of product for a cybersecurity company, a couple patents there, teach at UVA, DNC front-end developer. I was not the cause of the hack. And before that, I was a statistician for the Pentagon White House. So I've been around for a lot of different things in public and private sector, and everybody struggles with optimization and A/B testing. It is universally hard to do. So one quick story to kind of set the table. A few years ago, I was in Hong Kong for a business trip at an Airbnb, jet lagged out of my mind, a little tipsy, because what else are you going to do at 3 a.m.? So I get an email from my boss like, hey, we'd really like this demo. So I was like, okay, well, I've never built an iOS app before. I'll figure it out. I'd heard of React Native. I said, let me give it a try. And like 10 hours later, I stood up a nice little React Native demo app that kind of like showed off our protocol and all this cool stuff. I bring that up because that code base that I sort of drunkenly made several years ago is the basis of a core offering of a major company right now. And that's terrifying. But it also speaks to kind of the value of React in that it is really easy to build something and roll it out and launch it. It is very easy as like a basic developer to get something stood up, a solid MVP. The problem is that you can go from MVP to alpha to beta to like launched product with that same code base very quickly. And if you have a CEO who's like banging on your door, it's probably going to happen that way. So that means things like A/B testing that require kind of architecture thinking, you have to build in early. It is not something you can actually wait to do on your beta product, because by that point, your architecture is already built, and you're going to have to recode a lot of stuff. So why is A/B testing in and of itself important? And for those that don't know anything about A/B testing, I'm going to just breeze through a quick refresher. So you've got two buttons. This is a classic issue. This is one from politics that I know of personally. So we had one button. It was submit. It was red. We tweaked it. We said, hey, let's make it green and change the word donate. That one change increased our donations by $100,000 a month. That is an absurd amount of difference for a color and a word. But those are the things you can kind of discover. So here's a quick one for you guys. Raise your hand if you think the subject line from A is better than the subject line from B. So all in favor of A. A couple hands are there. All in favor of B? OK. So mostly the same subject line. B has a 100% increase on click-throughs. I don't know why. People are weird. But like, you got to discover this stuff. And part of the hard part of A/B testing is it is sometimes unintuitive, the things you discover. If you had gone the other way, if you'd started with B and then changed to A because, oh, it's got an exclamation point, it must be better, you would be, have a massive drop in your click-throughs. So what is A/B testing? Quick refresher on the stats. So it is, on the continuous data side, it's actually based off of something from 1908. It's the student's T statistic. The student is not a student. It's a pseudonym by this guy, William Gossett, who's a biochemist at Guinness. So A/B testing was originally used to sample what version of their beer that they were brewing was better, which I think is pretty cool. The big important thing is it is not a normal distribution. It's fatter and shorter, and I'll talk about why in a second. It's mostly about comparing mean versus mean, and evanmiller.org is a great set of like tools that will essentially do all the math for you. You just got to sort of understand what you're looking for. And then the other kind of piece of A/B testing you guys might see is discrete data, so that kind of click-through rate, which is usually the n-1 Pearson's chi-square. You don't need to understand much in that. Just know that it's successes out of opportunities. And that's exactly the one we're going to talk about today. So why not the normal distribution? Why is it not that thing you learned about in high school and college? Because the variance is unknown. When you're building new components, you don't actually know that the variances is going to be beforehand. So the student's T statistic is essentially a sort of flattened normal distribution because it is a risk-averse approach. And also, it works really well for small sample sizes. So you might think, oh, I've got 10,000 users on my site. That's really cool. But the actual people that are going to hit one specific
test and variation might actually be really small. So like 6% click-through on one form, then you go to, okay, of the people who see the form, who actually completes it? So the numbers actually go down pretty quick in web traffic. So that's why, again, the t-statistic is much better than the z-test and normal distribution. And here's the quick math that you can look up later online if you're really interested, but I'm not going to go into it. So there are a lot of tools in A/B testing. There have been tools for a long time. Google started this with kind of their 41 flavors of blue. Their first A/B testing was actually a total failure. They screwed up the code. But it was developed with largely a static DOM. So it was a jQuery-like library dropped in your header, and it manipulated your page on load. So you've got that red button in your code base, and boom, it'll swap it to green on page load. So Optimizely was really good at this. They were used in the Obama 08 and 2012 campaigns, and they had big ties to Google. VWO is really good, Convert.com, things you've heard of. So the problem is React rebuilds the DOM over and over and over again, right? It is breaking and erasing all of those nice manipulations you built in Optimizely. So kind of big womp womp there. So I'm going to talk about kind of 3 paths to fix this, to kind of get over this gap that, that these kind of jQuery-ish libraries have left. So first, the app lifecycle. So we all should be familiar with the React app lifecycle. This is a quick and dirty way to do this, right? So you've got your app component at the top. You've got your it did mount, component did update, and every time it does that, it calls those functions. You just go to your window object, you pull out, I'm going to use Optimizely an example here, Optimizely.hook, Optimizely runs its little JavaScript code, and boom, you've made your manipulations. The problem with this, so here's the, what the code in Optimizely would end up looking like. CSS selector is really basic stuff. The problem with this is, the DOM manipulation is still outside the virtual DOM, so it's going to be slower. It's like I built this great app, and I got all the benefit of the virtual DOM with React, and I'm throwing sand in it, like literally with every render. So not a great idea. It's also disconnected from the client-side component logic. So the logic of Optimizely in your experiments is totally separate from your actual application. And it really is only going to work on kind of small changes. Oh, I'm going to change that button. But if I want to swap out an entire component, this breaks down really quickly. But the pros are you get to use Optimizely, so your marketing team really likes you, and it's very quick and dirty. Second approach. So we're going to bring like kind of the Optimizely-ish library into a component. React is component-based, so this makes sense. So we're going to essentially do the variation manipulation at that higher order component. So that really some pseudocode here. You got the app, the header, the experiment, and then in that you've got a couple variations. So that experiment higher order component is going to decide which variation to show. Right? Very simple kind of swap React logic. So this is some sample code. Again, all the code is on GitHub, and you can find it in the end of the links at the end of the slide. Feel free to use it. So this is very simple code, but like you can see that in the get variation function, it is pulling out the Optimizely data object. So when Optimizely pulls its code down on that page load, it pulls down essentially a big object about telling you what all the experiments are. So this is, hey, does this experiment apply to this component? Oh, it does. OK, does this particular variation apply to this component? Yes, it does. Great, show it. So pretty simple logic, but you're in the component now. So then, of course, what you end up seeing is kind of your variation IDs, which are tying to your Optimizely logic, and one kind of wrapper higher order component. And of course, credit to sheshbabu.com. So pros of this, you still get to use the Optimizely interface. Your marketing team loves you. You're using the full component structure. Yay. And you're inside the virtual DOM. Great. You've crossed that big threshold. You're sort of using React correctly with A/B testing. The cons, you are splitting up your state management. So now you've got Optimizely sort of doing some logic about it knows what it's supposed to be happening, and your app doesn't really. You're still disconnected from component event logic. So your components are actually passively receiving information from Optimizely about what the experiments are. It really can't control it, right? So that one-way flow in but no way out leaves a lot of room for issues, and it kind of cuts you off the knees when you want to do things more complex. So the win events, so you think about the successes out of opportunities that we talked about earlier, the win events have to be collected in some other way. And of course, this does not play well with Redux, which is, I think, kind of becoming a pretty big standard. So the third option, and this is the option that we use at work.co and with Mount Cleverest. It's a hodgepodge of a couple of libraries that I saw out there that none of them quite could do this, but we brought this together, and credit to the team over at work for helping with this. Here's the basic lifecycle of Redux, right? UI triggers an action, dispatches out to the reducer. Reducer makes a immutable state change. Goes to the store updates state, trickles all the way through. So if you are going to be tracking a lot of behavioral data about what's going on in your app, Redux is a great way to do it, because all of those actions, everything your user does is essentially probably going to be an action, dispatched in some fashion. There's a great tool called segment.com. If you're not, it used to be segment.io. Segment.com, I love it. It's a great tool. It is like the behavioral event warehouse. You just throw all your platforms into it, just points to the same warehouse, it cleans it up, and then pushes all that data back out to all the various consumers that you might need, whether that's a BI tool or whatever. Segment.com. So what I found was that Segment actually has a nice little plugin for Redux, which will act as a middleware, capture the events that are coming out of the reducer, say, hey, is this an event that looks like a Segment qualified event, something that Segment cares about, a behavioral event that someone in the BI tool, whatever, is interested in. If it is, great, send it to segment.com, just dump it out there. And then it kind of gets out of the way very quickly from the Redux state loop. So this is actually a really cool idea, and I thought this is pretty valuable. How can I use this? Also, how can I get my A/B testing data, all of my experimental data, what people are doing with one variation or the other, into that same flow? Because if I have a BI tool, I don't want to have to go to Optimizely to look up one thing and then my BI tool to look up everything else. So this is a way to get your event data and your behavioral event data and your experimentation data kind of in the same flow to the same resource. And this same structure can be used without segment.com. You can pump this data anywhere you want, but that's what we use. So what's this going to look like? So you have that original event object or action, kind of standard. You got your type, and then whatever data you're going to pass along. So with a segment event, it's a very, very slight modification to your event or your action inside your Redux code. All you're really adding is that meta object with your analytics and some segment-specific stuff. But that's all it is. You're just appending that meta thing and saying, hey, this is the stuff that I care about and I want to track in segment. And it handles the rest. It is pretty slick. So when you log into Segment, you see some cool stuff like this. So it's tracking all of these events, the time codes. It tells you what happened in the kind of pretty format. So Segment does a pretty good job at handling all that stuff. And of course, you can pump it all into Redshift or Postgres and kind of handle that way too. So let's talk about the actual middleware. How are we going to make the Segment middleware work to our advantage for A/B testing? So I said, great, I'm going to just make my own middleware and just shove it right ahead of the Segment middleware. So I know that every time I do an event, every time I do an experiment, I'm going to have essentially two actions that I care about. That a user is playing the experiment. Oh, great, like I'm seeing the registration form. And then whether they win. So I'm playing version A of the registration form, or I'm playing version B of the registration form. And then when I click register and I complete, that triggers a win. So great, that user got through the win. So there's a success and an opportunity, right? Goes straight back to the math. So I built a really lightweight middleware, and all this is doing is it's looking out for any actions of type play and type win. It takes in some data from the component or from that was called with the dispatch, converts it to a segment-friendly object, and then pushes it right into the segment middleware, which then pushes it to segment, and the Redux loop continues on. So very kind of computationally pretty simple stuff. This should look familiar. This is a lot like Path 2 that I talked about earlier. So this is, and again, a higher order experiment component with some variations inside. So what this is doing is saying, great, I've got an experiment named registration form variation. I've got two variations, one that has some extra text, one that doesn't, and then the component inside of that. This is exactly what we were doing before. I'm just rebuilding it for this Redux version. So what does the function look like? What is that win function? So in the higher order component, I'm actually going to pass the kind of on register event, that click. I want it to actually be managed at that higher order level so that both versions, both variations are calling the same core function. So all that does is say, great, tell me what experiment and what variation got passed down. Tell me where I'm at. Send that data along the segment. That's it. Click the button, send the data. So this is, again, let's say you want to, you got to, of course, get your experiment structure in. And this is where the kind of the downside of this one approach is that I have to manage my experimentation inside the code base. You could swap out your code base and say, I'm going to use that optimizely data object. But if you notice this section right here, variants, I'm essentially doing the same thing that the optimizely data object is doing, describing my experiments. I'm just doing this when I initialize state at the very beginning of the React app. And then I throw it in, again, when I create the store as some middleware. So this is my experiment middleware. It's the thing that's doing everything else that we just talked about. So pros of this approach. It's optional use of optimizely interface. It's using, again, the full component structure. It's inside the virtual DOM, which is what we wanted. It's utilizing Redux state and store, which is really good because I think a lot of people are using Redux these days. And the win-losses are contained inside the functional flow, which is a big difference. This means you can call a win or a play event from anywhere in your app in the same structure and see that data pumped into your BI tool. The cons. It is a little bit more complicated to build, but not impossible. It must be adapted to your own stack. And of course, it requires code deployment for new experiments. So now what? Let's say you've built this thing, and again, all that code is available on GitHub. Feel free to use it. So future improvements. This kind of gets blown out of the water when you start talking about server-side rendering or static rendering logic. It's not impossible, though. You're still going to get like that flash of whatever version the server decides. If that's not the one that is cookied in the user because they've already been to the site, then you're going to see a flash of the wrong module. Static render, you're going to see a flash of no object, and then suddenly the object as it has to kind of wait. So the initial render is going to miss the benefit of that static render. Still haven't quite figured that out. If you've got some great ideas, I'd love some help. We've actually been experimenting with moving the experimentation and deciding what the experiment should be in CloudFront at the Lambda edge. So running a tiny little serverless function every time we refresh the cache that decides like, hey, this user with this cookie should get this version of the experiment. And that way it's getting passed down as part of the initial payload. And that means you can kind of skip around all the server-side and static rendering stuff. So gotchas. The novelty effect. So when you're looking at your end result data, don't assume that the variance that you're going to see at the end is actually going to be stable. So heteroscedasticity is the fancy word for this. Users are probably going to settle into experience. So they might be like, ooh, the interface looks really cool or new. I'm going to click that button. So those tiny changes of just showing a new thing can get users excited. And you really need to, anytime you have that kind of new experience with old users, you definitely want to make sure you drag out your experiment a little bit longer. Statistical significance. This is the big mistake that everyone seems to make, is that as soon as you cross that statistical significance threshold, you type in your numbers on that little web form, you're like, oh great, we're statistically significant. You stop. That's a terrible idea, because that statistical significance is just another measure, and it will bounce up and down over a while. Eventually, it will converge to something. But this is where sample size, deciding the correct sample size is very important, and you should stick with it. And don't even tell your CEO that you've got some kind of data, because if you do, and you give him or her like the opportunity to make a judgment on what is essentially incomplete data, they will. They will always move faster. So this is just avoid it, right? Say, oh, we got to wait to 3,000 users. So how do you know that it's 3,000 users? So minimum sample size is the other kind of big gotcha. Real changes are hard to detect in web development. Again, Evan Miller has a great sample size calculator. But think of the distinction, the subtle difference here is like a 10% conversion rate on a page with a 2% detection. So I'm detecting anything outside of 8 and 12. I need 3,000 users, roughly 3,200 per event. For 8% conversion on a page and a 1% detection, so I'm going from 7 to 9, that is a 10,000 users per variation. That is a 3x difference in the number of experiments you run. So this could drastically change the kind of like tolerance that you're looking at for like, does my experiment actually make a difference? And again, this is not math that is super complicated. You just need to know what to plug in. So again, Evan Miller really helps with that. So this is what the tool on Evan Miller looks like. Baseline conversion rate, minimum detectable effect, and it just tells you sample size. So again, these are all the credits for the team that help with all this stuff. All the various packages and things I drew from and have looked at over the last year, kind of building this stuff out, is all there. So any questions? The question was, is it worthwhile to run A/B testing if you don't have a huge sample size? No. So what I say, like A/B testing is for optimization, but I brought up that story in the beginning about kind of Hong Kong because you want to build this into your structure early so that when you do need it, it's there. And you can build experimentations early on, and like it will slowly cross that threshold. But yeah, it's going to take a little bit longer to reach the threshold of sample size. But so don't expect to get results in a week. But you might get results in a month or two, which could be very indicative if you've got an MVP that you're working on for a while. So the question is, can you run multiple experiments at the time and determine which is impact the variable? It depends on how you structure the app. So again, this is the value of connecting the win event inside your application logic, is you can say, hey, when I randomize my experimentation in my initialization state in the Redux store, when I initialize it, I can say, you either get all of these or all of these, or you can get this one and this one and this one in sequence, or this one and this one and this one in sequence. So there's a lot of variation from a data management standpoint. As long as you are collecting the various events and you've got the win events, you should be able to create a profile of everything the user has ever done and draw simply a multivariate model against that later if you really want to say, oh, is there some cross-pollination? But usually you're going to have an event like, I loaded the registration page and I saw the registration got clicked on version A, not B. So it is usually pretty tightly coupled just in the structure of the code itself.